Come in a bit. Right, so we just unboxed our pick and place machine. Now you all did your PCBs right at the beginning of this C721. Now we were hoping to have this running this year because what we wanted to illustrate to you is rather than having to tediously solder all these components on and put them on with tiny little pliers and so on and get them all lined up and everything, here's a machine that does it for you. Mike, do you want to talk us through what a pick and place machine is?
So pick and place machine is basically going to take some components, surface mount components, and it's going to pick them up and place them on the board. How it works is it's got an XY axis here. So when you generate your board, the Gerber files for your board, you can also generate a pick and place file that automatically knows the coordinates that each one of those components are supposed to be placed on a PCB. So you come along to a machine like this, you generate that file. All of these are called feeders. And at the moment all we have are the roll feeders. So when you buy components, for example resistors, you'll buy a reel of 5,000. You'll put the reel onto here, these turn around, and you feed the reel end up to this point here. And you'll do that for all the values of the components that you've got on that board, because you also generate a BOM, which is a bill of materials. And that tells you what components you've got on that board. So you'll set this up with all the components you're going to use. You'll feed in your Centroid file, which is your pick and place file from your PCB, and you press go. And this puppy here will move along the XY axis. It will come along, it will pick up a component and place it exactly where it's supposed to go. Obviously, before you go through this point, you have to paste the board. So every single pad on your board needs to have solder paste added to it. And when we send the board off from manufacturer, the manufacturer will ask, do you want a stencil with this board as well? And a stencil, when you were doing your Ulti board, you also had a paste layer that you could change. And what that paste layer does is they use that to make a stencil. And they take a piece of aluminium and they cut holes in wherever that paste layer has got a hole. And then your board will turn up and you'll place the stencil on top of the board. You'll get a lump of solder paste with a squeaky and you'll wipe it over the stencil. And then that solder paste will go through all the holes on the stencil. And when you lift the stencil off, you've got little bits of solder paste in perfectly the right areas. You then put this board onto here, you run the pick and place machine, it picks up the components, places it all in the right place. You carefully then take your board to a reflow oven, put it in, the reflow oven will heat up the solder paste, reflow the solder paste, solder every component on there, and the job's done. So what this will do is all that nasty work that you have to do with your hands when you're building your board. If you've got a component that needs orientation, it also knows about this. So if there's a pin 1, like your ICs, it will pick up the component, normally from a different type of feeder, tube feeder or tray feeder, and it will move it over to this camera here. And then this camera will look at the orientation of that component, correct it, and then put it on the board. And that happens very quickly. And that's all there is to a pick and place. It's a very nice piece of kit. Hopefully we can get that running for next year.
So for the audio amplifier, Mike, we've said this before, but how long would do you think that machine would take to build the audio amplifier?
On a big one in a proper PCB fab area, that would take seconds to do, because these things run so quickly, and sometimes they've got multiple heads as well that are working together, so they're very quick. But this one, I would expect it to take less than a minute to place one of those amp boards, much less, half a minute or something along those lines. But normally when you make the boards, you'll make one little, like that amp board we had was quite small. You would do what's called step it up, and so what you'd end up with is a panel, and that board will be stepped up on the panel, so you have the same little circuit board 16 or more times on one panel, and then you place the whole panel in one go. And the panel will have fiducials, which are what's used to be able to detect the reference point, the 0 point of your X and Y. And it also allows you to properly align the stencil so that when you're pasting it, you've got a reference point that everything can click together and you know that you're going to have a proper registration on there. Yeah? So a fiducial is also used by this camera. So there's another camera on here. If you have something like a BGA part, something which is very important that you get that exactly the right place on the board so that when it reflows everything falls in the right area, you'll put a fiducial on the board, which is an additional reference mark. And you'll tell this, I've got another fiducial there. And what will happen is this will have a crosshair on this camera, and it will move over, pick up the critical alignment part, move over to that fiducial, put the crosshairs across it, adjust itself, and then put the component down. So it's just a secondary reference, so if there's any non-linear error or something within this machine, it can deal with it.
Okay, brilliant. Anyone have any questions on that? So when you go out, and if you do get a job, which is almost certainly for a small to medium enterprise company, that's the kind of thing that you'll be using, and one individual could turn out dozens and dozens and dozens of printed circuit boards a day using such a machine. So really everything that you've been doing, but dramatically accelerated. Brilliant.